Question 13. ABC is a right-angled triangle. The diagram is not accurately drawn. AC is 6 cm and AB is 13 cm. Part A. Work out the length of BC. Give your answer correct to 3 significant figures. So if we're dealing with a right-angled triangle and we're trying to find one missing side and we have 2 others, what we're looking at is Pythagoras Theorem, which says that if we square the longest side, that's equal to the sum of the other 2 sides squared. So, because we know the longest side, if we square both of these values, take them away, that will be the same as the square of this value. So to find the length of CB, which I'm going to call in this case CB squared, is equal to the hypotenuse squared, so 13 squared, take away 6 squared. 13 squared is 169, take away 6 squared gives us an answer of 133. So to find out what the length of CB or BC actually is, we have to square root our answer. Now the square root of 133 comes out as a very long decimal. 256, 259, etc. It keeps going. But we're supposed to give our answers correct to 3 significant figures. So if we count from the beginning, 1, 2, 3, we're going to round off our answer after the 3rd significant figure. The number after the line is smaller than 5, so it stays as it is, which is 11.5 centimeters. Question B is a different triangle. Again, not drawn accurately. PQR is a right-angled triangle, where PR is 17 centimeters, PQ is 25 centimeters. Question B asks us to work out the size of angle RPQ. So that's this top angle here. Give your answer correct to 1 decimal place. Now this time we're not dealing with 3 sides, so Pythagoras Theorem will not apply. Instead we're going to be dealing with trigonometry. We have to identify which of our trigonometric rules we have to use, and then just substitute the values in. And the way I always do this is using a catchphrase which most people will have learned called Sohcahtoa. But the way I write this is like a pyramid. I have So, Ka, Toa. Putting the middle letter of each miniature word at the top, because this will help us when we're trying to make the calculations by showing which way to divide or multiply. So out of all of these, which ones do we know, or are we trying to find out? Well, we know the hypotenuse. It's this longest side opposite the right angle, so we can circle off the hypotenuse. We also know the length of the side down next to the angle, down the left-hand side here, which is the adjacent side to the angle. So we also know the adjacent. What we're trying to find out is the angle, which means we're either going to be able to find the sine of the angle, cosine of the angle, or the tangent. And quite clearly it shows that we're going to have to use cosine for this question. Now why did I write this as a pyramid, you might ask? Well, we have our adjacent is above the hypotenuse, which shows that we're going to divide the adjacent by the hypotenuse to find out what the cosine of this angle is. Now for the purpose of the question, I'm going to call the angle x. So the cosine of this angle x can be found by taking the adjacent side, which is 17, dividing by the hypotenuse, which is 25. 17 divided by 25 gives us 0.25. 0.68. So if the cosine of x is 0.68, we can find x by finding the inverse of this, which is probably shown as cosine with a negative 1 above it. Now the computer calculator doesn't have that button, but I believe it does have an invert function here, which will show us cosine to negative 1. Pressing that gives us a very long number once more, which is 47.1563 to 56956, and that again continues on for a long time. But to give our actual answer, it says give your answer correct to 1 decimal place. So we cut off after 1 decimal place here. The number after it is 5, which means it's technically closer to the next number above. So we get 47.2 as our final answer.